All right, so I've had a few questions about how to do texture analysis in ENVI, so I wanted to show you how to do this. Now, this is going to take a lot of like CPU power from your computer, so expect it to take a while, so go have a coffee or eat lunch or something while you're waiting. But to set it up is actually really relatively easy. So once you have your resize image in the layer manager, and you can see that I've got that there, you can go over to the toolbox and you're going to find filter. And under filter, you're going to look for co-occurrence measures. So that's actually like one of the scientific names that we call texture analysis. So you're going to look at this co-occurrence measures and you can double click it and it will open up into this particular window. You're just going to highlight your resize stack image. And you can keep all the bands in there if you are planning on running that. If you are using Landsat 8, make sure that you're only using the optical bands for this, because if you use anything outside of like the panchromatic, or if you use the panchromatic or the cirrus or the thermal, it's going to add extra noise to your image, so we don't want that. So we want to keep it in the optical, which is the coastal aerosol to the shortwave infrared. So then once you've highlighted it, then you can press OK. And then you'll come to this parameters page. I suggest taking all of them for now. I don't expect you guys to be able to understand every single one of them, but at least if you have them, you might be able to see something within your actual image itself. So the smaller the window, the more precise it's going to be. The bigger one is going to be more blotchy. So I'm going to do 3x3, or I did 3x3 in my first example that I'm going to show. This time around, maybe I'll do maybe 15x15 just to reduce down the size of the window. But for you, you can certainly use 3x3. Play around with it, see how it does. And you might find that one looks better than the other or tells you more information. Of course, the bigger the window is, the more it generalizes the image. So then I'm going to go and I'm going to save this one. So this one is going to be my texture 1515. And I'll have my year in there for 2001. Press open. You would have 3x3 for yours. And then you can press OK. And it's going to take a little while to run here. So I think my last one took about 5 minutes. So maybe while I'm waiting for it to process, I can talk about the different metrics that you're going to see when it comes out. So with texture analysis in ENVI, there's kind of two parts that happen. There's the occurrence metrics, and then there's co-occurrence metrics. So we're actually calculating this co-occurrence metrics in ENVI. And so what that means is that you're doing kind of a chessboard style calculation. So we're looking at all directions from the single pixel that we're looking at. So it uses a window, just like we do with filtering, like convolution kernel, except this time around it just looks at the numbers itself. It doesn't actually like do anything else with it. So then it takes that and then it would say, okay, which, so for example, it shifts right by 1 and next to the next one. So it's like, do these values match? So for example here, the co-occurrence matrix tells me how many 3s do I have in my in the image. Do they relate? Do I have a 3 to a 5 that's right next to each other? So right there I've got 3 and 3, so 3 to 3. Do I have a 3 beside each other? In this case, we're looking at the second one because it's moved over. So no, I don't. Do I have a 3 and a 5? I've got a 3 and a 5. I've actually got a couple 3 and the 5s. So it says that I've got 3 and 5s next to each other. 1, 2, and 3, right? So we can count that. So we got that in the matrix, and ENVI creates this matrix for you, so you don't have to do that. And this will not show up on an exam. So this is a little bit higher level than what we need. Then we can look here and it says, do I have a 3 and a 4 together? So I go around and, oh, there's a 3 and a 4. And there's a 3 and a 4, so I have 2 of them. Perfect. And then down here I've got 5 and 6, so do I have 5 and 6 together there, 5 and 6 there, I have 5 and 6 there. So I actually have a few of them, more than what it's actually listing here because it's only got 2. So there's that, and then I've got the 4 and 6. So where do I find that? Those ones there, and then I've got another one there. So if I look over here, it's the same thing. So looking at this co-occurrence matrix, it creates this co-occurrence matrix, like of all 3 by 3, for example, in this case. It looks at it and says, how many times does it change to these numbers? And it will identify that. So then it calculates mean, which is the average value of the pixel, or the kernel. So that's the average value of the actual window that it did this calculation in. Then there's variance, which is the variance. We have homogeneity, which what homogeneity is a measure. It's actually providing a value for how homogeneous something is. Contrast means how strongly are those pixels different. So for example, a value of 3 versus 6 is going to have a higher contrast than a 3 versus a 4. Dissimilarity means like how different they are. Entropy is kind of how one reacts to another. Like if I often have a change of 3 to 5, then does that relate all the way through the image? Do I see that same pattern? Moments, I'm not going to get into that. It's based on angles. So it's like, what is the common angle at which those values go? And then correlation as well, which is how well are they correlated? Like, do we see that correlation within that little pixel? So still thinking here. And so you can get this under the l3harrisgeospatial.com/docs backgroundtexturemetrics.html. So there's all that information in here. Again, I am not expecting you guys to go and do all this math. Okay, so, and even if you don't fully understand it, that's okay, because once we get to the final result, it will show you how to you can look at it and say, does this actually identify certain features in my actual image? So my recording software does not have a pause button in this one. So I'm going to just kind of mute myself and just let this run, and you can just watch that if you want, or you can just fast forward to the end, or close to the end where I actually showed the result. So yeah, so I'll just mute myself, and then we'll just wait and see what happens. All right, so if you get this error, again, just ignore it because it doesn't really matter. And then we end up with our result. So you can see here, this is a composite of 3 layers. So if we go over here, we can see it's homogeneity, variance, and mean. So if the mean is really high, what does that tell you? But really we're looking at homogeneity, which ones seem to be the most homogeneous. So we can see that the city is obviously not very homogeneous. If I take that off and bring it back on, there's like no value for homogeneity. Where over here and out here we're seeing a little bit more homogeneous information. And you might find that, like zooming in, for example, here in these in the crop regions. So if I go down into here, I can turn that on and off. You can see how a lot of the regular crop sizes look okay. Now if we look down here, which looks like more of a range area, it's still showing homogeneous, which is, in this case, I guess it might be a lot of trees or something that's showing up homogeneous. But you can see that the ones around it that have like a transition are not showing as much. Again, you can always go to the data manager and there's all kinds of information in here. So if you were to pull up each individual one, you might find that, for example, here, and again, I have this at really large pixel sizes. So, maybe the mean will show, or maybe if I come in here, maybe my correlation will show better what I'm trying to look for. You can see what happens when we do these calculations. So they look really funny when you look at them individually, especially with these larger, like the larger window sizes. But if I go and I were to open up one that's smaller, so I already had the data manager open. So right here, and I went into this one. So let's say I wanted to do the same as what it shows there. So this is the difference between a 3x3 versus the 15x15. So you can see a lot more detail with this one. You can see the edges are better defined. So the smaller the pixel size, the more detailed it's going to look like. And maybe perhaps in these regions where I have like rangeland versus like cropland, I might see the difference in there. And again, changing the composites around, changing the values, not the values, but changing which layer you're looking at will definitely help. At times, you'll have to go back and forth. For example, here, I can go back and forth between these and to see, can I see a difference between, for example, this crop regions up here and versus like the rangelands down here? Am I noticing any patterns? Now, with this particular composite, it doesn't seem to help me identify the difference between them, except for the city. So if I'm looking at the city, I'm going to definitely see that, whoops, that's not what I wanted to do. In my hand. If I go up to the city part here, we know that going here, we're definitely going to see, again, that difference. So the city is showing very low homogeneity, where out here it's showing more, even in the forested areas. So that's homogeneity. There's dissimilarity as well, so take a look at those, see what that's showing you. Take a look at it, because it's showing you the edges, right? So it's almost like an edge detection in this case. Entropy might have some information in there for you as well, again showing that the edge component. Correlation, how well does it, you can see that we're almost creating polygons in a lot of these. So take a look through them, see if you can find something that helps you relate those values. Look at them in numerical values as well. But these images will provide you with an end result that should help you with your with looking at your information. So the other thing, too, to keep in mind is that I've just been using the coastal aerosols, so that may not be very helpful. So you might find that you have to come down to the near infrared, and maybe that will give you a totally different result. Okay? So each of these bands have been separated up and calculated in many different ways, right? So go through your data, look at what each individual result is showing, And you can see how big this database is, all the way up to shortwave infrared. So depending on what I'm looking for and what information I'm trying to gather from that, so this one's from the 15 by 15, I might be able to identify more features, or at least delineate some features that have more of a homogeneous look to them versus a more sustainable and heterogeneous, I guess. Heterogeneous is the word I'm looking for. Heterogeneous perspective. So that is how you do this in ENVI. You have to run this co-occurrence measures filter on your image, and it will just do the whole thing for you.